Good morning, students. Hope you all are doing good. Welcome back in your chemistry class. In the series of family of salts, we will learn some more salts today. In the last video, you have done already caustic soda and bleaching powder. Now see the baking soda. Soda commonly used in the kitchen for making tasty crispy pakoras is baking soda. You know that in mostly kitchens, baking soda is very common. It is used in many preparations. It is used for making the cooking faster also. If pakoras are crispy, it is because of addition of this baking soda in that as a raw material, right? And this baking soda is not used in much more quantity. It is used in a very little quantity. And chemical name of this baking soda is sodium hydrogen carbonate. You can see the formula, sodium hydrogen carbonate. And it is produced using sodium chloride as one of the raw material. You have seen that this sodium chloride is the raw material of the preparation of caustic soda also, that is sodium hydroxide. And here in the preparation of sodium hydrogen carbonate or the baking soda, again it is a raw material. And the reaction which takes place is sodium chloride, that is NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. You can see when it is heated, it releases carbon dioxide, and this is the carbon dioxide which makes your cakes fluffy, because it is an ingredient of the cakes also. Your cakes become soft and spongy because when it is heated, it releases carbon dioxide gas. It is a mild non-corrosive base. You know that it is not a strong base. You can touch it. And the reaction which takes place during cooking is NaHCO3, that is sodium hydrogen carbonate. When it is heated, it forms sodium carbonate, water and carbon dioxide. This sodium carbonate is again washing soda. So you can see when it is heated, it forms washing soda also, that is sodium carbonate. What are the uses of sodium hydrogen carbonate? As I told earlier, that you have to learn the preparations as well as uses also, because uses also are asked in the question paper. As I told you that it is an ingredient of your cakes also, right? Other than that, it is used for making baking powder. Baking powder is also used in many preparations, and this baking powder, it is a mixture of baking soda and a mild edible acid. Edible acid means which can be eaten, right? Such as a tartaric acid. Tartaric acid is also used in some preparations. So when baking powder is heated or mixed in water, the following reaction takes place. So when it is heated or mixed with water, then it releases carbon dioxide, and this H ions are from any acid, as the tartaric acid is used here. In the same way, if tartaric acid or any other acid is used here, these H ions are from that, and the sodium salt will be formed of that particular acid. So carbon dioxide produced during the reaction, this carbon dioxide, this causes the bread or cake to rise, making them soft and spongy. Next use is, it is also an ingredient in antacids. You know that many times the people have the problem of acidity. So they used to take antacids, and these antacids contains base. So which base they generally contain? Like sodium hydrogen carbonate, that is baking soda. Because it is alkaline, it just dissolves in water and neutralizes the excess acid in the stomach and provides relief. You know that people used to take ENO also, that also contains baking soda or sodium hydrogen carbonate. It is also used in soda acid fire extinguishers. Soda acid fire extinguishers are used for extinguishing fires. In that also baking soda is one ingredient or the raw material. Next salt is washing soda. Washing soda, its chemical name is sodium carbonate and the formula is sodium carbonate, that is Na2CO3, sodium carbonate. And the reaction which takes place, that is, you know that when it is heated, sodium hydrogen carbonate or the baking soda when is heated, it produces sodium carbonate plus H2O plus carbon dioxide. And when this sodium carbonate is added with 10 molecules of water, it forms washing soda, that is sodium carbonate decahydrate, because washing soda contains 10 molecules of water in it, right? And the formula for sodium washing soda or the sodium carbonate is Na2CO3. How this is arranged, you can see Na2 plus ions and then C, and with C you can see with double bond this O is connect, and with the two single bonds 2 oxygen atoms are there. So this is Na2CO3. Now again the same it is that another chemical that can be obtained from sodium chloride is Na2CO3.10H2O, that is washing soda. It is also called sodium carbonate decahydrate. So you have seen that sodium carbonate can be obtained by heating baking soda as we have done in the reaction, and recrystallization, when it is added with water, it is called recrystallization of sodium carbonate, gives washing soda. It is also a basic salt. What are the uses of washing soda? Number one is sodium carbonate, that is washing soda, is used in glass, soap and paper industries. It is also used in the manufacture of sodium compounds such as borax, and it can be used as a cleaning agent for the domestic purposes, and it is also used for removing the permanent hardness of water. You know that at some places the water is very hard, it has many salts in it. So for removing that hardness of water, this sodium carbonate or the washing soda is used. Are the crystals of salt really dry? Now you will see that whether the crystals are dry or wet, as in case of the sodium carbonate, that you can see this, whether it is dry or wet, because it has 10 molecules of water, so it is not dry, right? It is crystalline. Clear? So see in this test tube, copper sulfate has been taken, copper sulfate crystals. Copper sulfate crystals means it has the water molecules like CuSO4.5H2O, right? So it has the 5 molecules of water of crystallization in it. So when it is heated, you can see this is the boiling test tube in which it is taken, and you will see the water droplets here. So from where the water comes? It comes from this copper sulfate, and you know that what is the color of copper sulfate crystals? These are always blue in color. But as you will heat it and this water is removing here, it becomes white. And again on cooling, it will become blue because this water will be added here, right? Yeah, or if the white, when it becomes white and you add water, then again it will change into blue color. So copper sulfate crystals, which seem to be dry, contain water of crystallization. So what is this water of crystallization? That I told that it has a formula CuSO4.5H2O. CuSO4 is for copper sulfate and 5H2O means one copper sulfate molecule has attached with 5 molecules of water. These water molecules are the water of crystallization. So when we heat the crystals, this water is removed and the salt turns white. As I showed in the figure, that as you are heating it, this water is removing and it changes to white color. But again, if you will moisten the crystals again with water, what will happen? You will find that the blue color of crystals reappears. As you add water, as I told you earlier, then again the color changes to blue. So what is this water of crystallization? Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. As you have seen the washing soda Na2CO3 dot 10H2. So this sodium carbonate has 10 molecules of water. Or you can say 1 molecule of sodium carbonate has 10 molecules of water. That is water of crystallization. In the same way, if you see copper sulfate, 1 molecule of copper sulfate has 5 molecules of water attached with it. So this is what? This is the water of crystallization. 5 molecules of water are present in 1 formula unit of copper sulfate. Next salt is plaster of Paris. You know that 2 things are there. One is gypsum, one is plaster of Paris. You have seen that many statues and decorative items, or you can say pieces, are made by plaster of Paris. Even it is used in the for decoration purpose in constructions also, right? And it is also used in by the doctors whenever somebody is having the fracture, then also the plaster of Paris is used. So how? Because this plaster of Paris, when it is heated, when it is mixed with water, it changes to gypsum, right? And when gypsum is heated, it loses water molecules and becomes calcium sulfate hemihydrate, that is CaSO4 dot half H2O. This CaSO4 dot half H2O is plaster of Paris. So you can see that when gypsum is heated, it changes to plaster of Paris, and when plaster of Paris is mixed with water and kept, it becomes very hard, and that is gypsum. You know what is plaster of Paris? If you see that whenever the fractured bone is there and the doctor is just wrapping it with the plaster, it is very soft at the time, but it becomes hard later on, right? Because after mixing the water, after some time, it becomes hard. So this calcium sulfate hemihydrate is plaster of Paris, and the substance which doctors use as a plaster for supporting the fractured bones in the right position, that is plaster of Paris. It is a white powder, and on mixing with water, it changes to gypsum, once again giving a hard solid mass. This hard solid mass is gypsum, right? This is the reversible reaction. When gypsum is heated, we get calcium sulfate hemihydrate, that is plaster of Paris. And when plaster of Paris is mixed with 1.5 molecule of water, we get gypsum, right? And you can say that this 2 molecules of calcium sulfate share 1 molecule of water. The reaction goes on like this. This is calcium sulfate hemihydrate, that is plaster of Paris, plus 1.5 molecule of water gives gypsum, that is CaSO4 dot 2H2O. This is calcium sulfate dihydrate, and common name is gypsum. So these all reactions are very important. These all the salts are very important. So students, you will learn all the salts, their formulas, their chemical names, their common names, their uses, and their reactions. Right? Thank you all of you. Have a good day.